My name is Antonio Fortunato and I am Deputy Head of Crew Operations for the European Astronaut Center in Cologne. The topic of this lesson is the International Space Station. As a vehicle, we will discuss its modules, its main capabilities, and to a lesser extent, its operations. Let's start with some really basic facts. First and foremost, the size of the ISS. The ISS is a very large vehicle. It measures 100 meters across by 60 meters in length. And it is by far the largest object humankind has ever flown to space. To such large dimensions corresponds also a very high mass. At 450 metric tons, the ISS is also the most massive object ever flown to space. Just to give you some terms for comparison, if we take Mir, the space station that the Soviet Union and later Russia flew from 1986 to 2000, and incidentally the second largest object ever flown to space, well, the ISS is 3.5 times as massive. If we go even further back and we consider the very first space station, the Salyut 1, flown by the Soviet Union in 1971, well, the ISS is 24 times as massive as Salyut 1. Now, where is the ISS? Well, the ISS is a human habitat in low Earth orbit. And by low Earth orbit, we really mean a circular orbit at an altitude of 400 kilometers from the surface of the planet. The laws of dynamics tell us that at that altitude, an object must move at an orbital speed of 7.5 kilometers per second. 7.5 kilometers per second means that the station completes an orbit around the planet in about 90 minutes, which also means that the astronauts on board experience every day over the course of 24 hours about 15 sunrises and 15 sunsets. One important parameter defining the orbit of the ISS is the orbital inclination. The orbital inclination is important because it defines the maximum and the minimum latitude a spacecraft flies over when moving along its orbit. At 50 degrees, the ISS trajectory spans between 50 degrees north and 50 degrees south. And this is a very good range of latitudes because it's where about 90% of the world's population lives. Now, how does the ISS communicate with the mission control on the ground? Traditionally, space programs have relied on a large network of ground stations distributed all over the globe. The station could only talk and communicate with mission control when flying over one of those ground stations. Now, this has been largely the approach used in all space programs, with the exception to a lesser extent of the US Space Shuttle. Well, the ISS still retains the capability of communicating directly with ground stations, but it uses it as a backup, as an emergency type of communication link. The prime communication link for the ISS is via the tracking and data relay satellite system. TDRS is made of two components. There is a space segment and there is a ground segment. The space segment is a constellation of geostationary satellites. So it's a constellation of satellites at an altitude of 36,000 kilometers from the surface of the planet. The ground segment is composed of two ground stations, a main ground station in White Sands in New Mexico, and a secondary ground station on the island of Guam. The way the system works is the following. The ISS, as it flies along its orbit, is always in sight of at least one of the satellites in the TDRS constellation. And it can communicate with this satellite, and this satellite can relay information received from the ISS to either the ground station in White Sands or the ground station in Guam. And from there, data is distributed to mission controls, to the users that need this information. Now, in principle, the ISS could have uninterrupted coverage. We could always communicate with the ISS, but the TDRS is a multi-user system, so as a matter of fact, we only have uninterrupted coverage in very special situations. Spacewalks is one of such cases. Another case is rendezvous and docking of visiting vehicles. Also, we can claim uninterrupted coverage in case of an emergency. Now, we have talked about visiting vehicles. Visiting vehicles and visiting vehicle docking is one of the critical events in the lifetime of the space station. But what are the visiting vehicles that can go to the ISS right now? Well, if we talk about vehicles able to ferry astronauts back and forth, at the moment we only have one with such capability, and this is the Soyuz vehicle. The Soyuz vehicle first flew in 1967. Originally it was conceived really as a vehicle that was to ferry astronauts around the moon but without landing. Later on it became really the workhorse of Soviet and Russian human spaceflight and has been used largely for ferrying astronauts back and forth the Soviet and Russian space stations first and the International Space Station nowadays. We are hoping that in about a year from now the Soyuz will be complemented by two vehicles operated by commercial companies in the United States, SpaceX and Boeing, and those companies should start ferrying astronauts to the ISS in the 2018 timeframe. Now, the Soyuz, as I mentioned, is the only vehicle that is capable right now of ferrying astronauts to the ISS. But what about cargo? The Soyuz is a relatively small vehicle. It is possible to take some cargo on board. It is possible in principle to transfer some fluids from the Soyuz to the space station, but there isn't such payload capability available after you've put inside all you need to carry astronauts. So we have a number of cargo vehicles that can perform just that. On the Russian side, we have the Progress. The Progress has a payload capacity of about 2.4 tons, and it is a vehicle derived from the ISS. From the outside, the two vehicles look almost exactly the same. One way to tell apart the Progress from a Soyuz is to look at some, let's say, small features on the outside. For instance, the Soyuz has a periscope to allow the astronauts to monitor docking. The Progress obviously doesn't have one because it carries only cargo. And manual docking for the Progress can be performed, but of course is maneuvered by the astronauts on the ISS. The Progress is a very capable vehicle in many ways. First of all, it can be used, for instance, to reboost the orbit of the space station. It can be used to perform orbital maneuvers, and this is an important capability because using the Progress allows us not to use the engines that are, for instance, available in the aft section of the service module. But also the Progress is rather unique because it can transfer fluids to the ISS, and I'm talking about fuel and water, directly through the docking collar. So the cosmonauts and the astronauts do not need to install any connection hose. They can just transfer fuel through the docking collar. And this is a unique capability that none of the other vehicles possesses. Now, the Soyuz and the Progress are the two space vehicles that are built and operated by Russia. But what is available on the US side? Well, since relatively recently, two private companies have been ferrying cargo to the ISS, and those companies are actually SpaceX and Orbital ATK. SpaceX is building and operating the unmanned version of Dragon. Dragon is more capable than Progress in terms of payload capacity to low Earth orbit. It can carry up to 3.5 tons of payload to the ISS. And what is really interesting is that it can carry both dry cargo, so pressurized cargo in the main volume of the capsule, but it can also carry unpressurized cargo in what is commonly known as its trunk. One thing that makes Dragon unique in the fleet of ISS cargo vehicle is the fact that Progress cannot just bring payloads up, but it can also return payloads to Earth. And this is an important capacity because sometimes, for instance, there is equipment breaking down and it is not possible to really understand what is going on without bringing this piece of equipment down and analyzing it on the ground. Also, sometimes we might simply want to take down equipment for refurbishment and later reflight. This has been a very important addition to the ISS capabilities after the fleet of the US Space Shuttle has been retired in 2011. As I mentioned, the other commercial company operating cargo vehicles to the ISS is Orbital ATK with its Cygnus. Cygnus has similar payload capacity as Dragon, about 3.5 tons, but it does not provide the capability of returning cargo to Earth. It can be loaded obviously with trash, it can be loaded with anything that is not needed any longer on the ISS, but this burns down in the atmosphere after the vehicle is unberthed from the station. Now, Dragon and Cygnus are vehicles operated by private companies, by commercial operators in the United States. There is one other vehicle that flies to the ISS that is actually operated by one of the partner agencies in the ISS program, and this is the HTV. The HTV is one of the Japanese contributions to the ISS program, and it is a very capable vehicle. It has a payload capacity of around 6 tons, and as with the Dragon, for instance, it can both carry pressurized cargo and unpressurized cargo. Now, enough of basic facts, enough of basic information about the ISS and its visiting vehicles. Let's really have a look at the main components of the station. And we will take our tour of those main components, talking first about the unpressurized elements of the station and later about the modules that comprise the so-called stack. So the collection of elements where there is a breathable atmosphere and where astronauts spend 99% of their time living and working in space. And just for clarity, the stack, so the pressurized modules, are what is here encircled in red. Everything else is unpressurized. Of course, astronauts can work there, but they can only do so during a spacewalk wearing a spacesuit.